Hello students, this is a video on how to solve area problems that are represented as quadratic equations. Now if you really think about it, the formula for the area of a rectangle is length times width. Anytime you have an application of something where you're multiplying something times something, you have the potential to end up with something squared in your equation, and that's exactly what's going on here. Now let's take a look at three examples. In this example, we have a coffee table that's shaped like a rectangle, and it is 3 minutes longer than it is wide, and it has an area of 10 square meters. Now we're going to try to find the length and the width of this coffee table. So let's start here. Let's always start by drawing a picture. So we're just going to draw a simple rectangle on our paper, and then we're going to label what we know. Now we do not know what the width is, but we do know that the length is 3 meters longer than the width. So I'm going to use W as my variable. Now let's set this up as a quadratic equation. Now the formula for area is length times width, as you know. So we're going to represent that as W times W plus 3, and we know, because the problem told us so, that that is equal to 10, the area. Now, we can't really work with this problem like this, but we can distribute the W and subtract 10 from both sides, and now we have it in the standard form and equal to 0, and we can use the quadratic formula to solve this problem. So let's get busy with that. Here's the quadratic formula, in case you forgot. We're going to substitute in A, B, and C, and then start simplifying. And we're going to end up with two answers. One says the width is equal to 2. The other says the width is equal to -5. Now, I think you already realize you can't have negative width. So that is what we call an extraneous answer. We're going to throw that out and stick with a width of 2. That means our width is 2 and our length is 5. Pause now and write down any questions you have about this, and at least copy down the problem. Here's our second example. The length of a photograph is 1 centimeter less than twice its width, and the area is 45 centimeters square. Now we want to find the length and the width of this photograph. So as always, we're going to start with a picture. Then we're going to label our picture. Again, we do not know what the width is, but we do know that the length is 1 centimeter less than twice the width. So we represent that by 2W minus 1. Now we're going to set up our quadratic equation. Once we have it written out this way with the length multiplied by the width equal to the area, then we're going to distribute the W across 2W minus 1, and we're going to subtract 45 from both sides so that it's in a form that we recognize, so that we can use the quadratic formula. All right, let's get busy with that. We're going to substitute in our values for A, B, and C. Simplify. We're going to end up with 91 under the radical. 91 can't be simplified anymore under the radical, so we're going to leave it like that. And since we are talking lengths and widths, we are going to convert this to decimal and round to the nearest thousandths. So here we are. We have a width of 5.27 centimeters and a width of -4.27 meters. That can't have a negative width, so we don't want that. We're going to throw that answer out and use 5.27. That means then our length is 1 centimeter less than twice the width, which is 9.54 centimeters. Now let's look at our third and last example. The length of a rectangle is 3 more than twice the width. The area is 27 meters squared. What are the length and width of this rectangle? All right, we're always going to start by drawing a picture. We do not know what the width is, but we do know that the length is 3 more than twice the width. So we're going to label our length that way. Then we're going to set up a quadratic equation. You see that here I have distributed the w across 2w plus 3 and subtracted 27 from both sides. Now that I know what my values of a, b, and c are, I can use the quadratic formula. You see that work here. I always calculate what's underneath the radical first. This one happens to be 225, and that's lucky for us because the square root of 225 is 15. Now all I have to do is calculate my positive and negative cases. So the positive case, the width is 3. My negative case, the width is negative 4.5. Can't have negative width, so I am throwing that case out. It's gone. And so my width is 3, and my length is 2 times 3 plus 3, which is 9. Now that's the end of this short video. I hope that you did take time to pause and copy down each example, and that you have also noted any questions you have, just to make sure that you fully understand this concept before any quiz or test. Peace out, peoples. I'll see you in class.